Alright, hi guys. We're going to take a look at our stoichiometry notes for those of you who missed class or just need a review on this process. So, we have looked at 3 different things so far in this unit to help us in doing conversions. So, we've looked at mole ratios, which use the balanced reaction coefficients. And those allow us to change chemicals in a reaction. We've also looked at using molar mass, which allows us to change between grams and moles of a chemical. And we get our molar mass from the periodic table. There we go. I'm doing this pretty early in the morning, so I might have some spelling errors here. And we also looked at molar volume. We use that for gases and allows us to change between liters and moles of gases. And that is probably the easiest one because it's always 22.4 liters is equal to 1 mole. So we've got these 3 tools that we can use to change our units around. We can go between grams and moles, liters and moles, and we can also change chemicals, and that keeps the mole the same. Our unit stays the same, but our chemical changes. So like moles of A to moles of B. So using those 3 tools, and sorry if you can hear my coffee pot in the background, we are going to approach these more complex problems. So our question here says, how many grams of NH3 are produced if 25.5 grams of N2 are used? So just like any other question, we want to find what we're given. So we're given 25.5 grams of N2, nitrogen, and what we're looking for. It's asking us to find grams of NH3. So this is a little different from questions we've seen before, where we're either just changing grams of a chemical to its moles, or we're just changing between chemicals using our mole ratio. This is a little more complex. We don't have a tool that goes between grams of a chemical and grams of another chemical. We can change grams to moles. We can change between chemicals using the mole ratio, but we can't go directly between them. So we're going to have to use multiple steps to do this. So we want to make sure we've got kind of all of our tools in place before we get started. We have our balanced reaction here. We have our coefficients on it. We can use those. We always have our molar volume. It's always the same value. But we need the molar mass of each chemical. So we're going to calculate that real quick. Well, the mass of nitrogen, 1 nitrogen, is 14.01. So we multiply that by 2, and we get 28.02 grams per mole. Hydrogen is 1.01 times 2 of them. We get 2.02 grams per mole. And our NH3, hydrogen 1.01 times 3 plus our 14.01 for the nitrogen gives us 17.04 grams per mole. So now we have all of our tools in place so we can solve any question we want with these using this chemical reaction, these values. So what we can do is if we're given grams of a chemical, the only thing we can possibly do with that number is change it to moles. So that's going to get us a step closer to being able to change from nitrogen into ammonia, or NH3. Because if we can get it to moles, then we can use a mole ratio and change our chemical. And that gets us one step closer. That gets us to the chemical we want. And then if we want that chemical in grams, we can just use another molar mass and get it to grams. So this is really a 3-step problem. So we're going to break this down. As usual, we're always going to start with our given amount, 25.5 grams, with its unit and chemical. We set up our railroad tracks. Automatically bring your units and chemical down. And then we want to figure out what we want on top. So the only thing we can possibly change grams to is moles. And the chemical doesn't change. We get that value from the molar mass. We have the molar mass of nitrogen. Nitrogen right here. So it's 28.02 grams. We always put it next to the number next to the grams in 1 mole or per mole. So we can calculate this first part. We always multiply on the top, divide on the bottom. So we have 25.5 divided by, move this over here so you guys can see it a little better, 28.02. And we get 0.91. And our units, our grams of nitrogen will cancel, and we're left with moles of nitrogen. So that gets us a step closer. That gets us to moles. Well, what can we do to moles? We can change them back to grams, but that's just reversing the process we just did. We can change them to liters, but we don't want liters at all. It doesn't talk about them at all. Or we can change our chemical, which is one thing we need to do in this problem. We need to change our chemical. So we're going to just bring down that answer. And again, set up our railroad tracks. So automatically bring that unit down. And then what we want on the top. We said we want to do a mole ratio, so we want to put moles on the top. And we need the chemical that we want from the question. It's asking for NH3. So for mole ratios, we get it from the coefficients on our balanced equation. So our coefficient on NH3 is 2, and on nitrogen is 1. So again, we want to multiply on the top, divide on the bottom. So 0.91 times 2 gives us 1.82 moles. And our nitrogen will cancel. So we're left with NH3. Alright, so we're a step closer. We've got to the chemical we want. So again, we can look at our options. We can change back, which we don't really want to do. We just did that step. We can change it to grams, which is what it's asking for. Or we can change it to liters. Again, it doesn't ask for liters, so we don't want that. So really our only option is to change this to grams. Get it to the unit that it's asking for. Set up our railroad tracks. Copy our unit down automatically, and then we want grams of that chemical. This always comes from the molar mass. We've calculated its molar mass already. 17.04 goes next to the grams always, and it's per mole, or in 1 mole. Multiply on the top, divide on the bottom, cancel our units. So 1.82 times 17.04, we get 31.01. At this level, so if other people are watching this, we're not dealing with all the rounding rules for chemistry. We're just kind of rounding off to a couple of decimal places since this is not an AP class. Alright, so this is not too bad of a process. It does take a couple of steps, but none that we haven't learned before. So it's a little clunky though to have to calculate and rewrite and calculate and rewrite and calculate over and over again. So there is a way we can set this up to do it in one long step with one long calculation. So I'm going to show you guys how what we did here translates to one calculation here. Now you might notice the units here. We've got the units we're starting with, and we'd always start with our given, that same 25.5. And what do we do first? We copy the units to the bottom, and then we figure out what we want. And then we end up copying the units to the bottom, and then we figure out what we want, put it on the top. And we copy those units to the bottom, and we put what we want on top. So that pattern, that diagonal pattern, will happen every time on this. And so it's a habit we want to get into, just bringing those units down so they'll cancel. So the first thing we did with this was we changed those grams of nitrogen to moles of nitrogen, and we used its mole ratio, or excuse me, molar mass. So it was 1 over 28.02 molar mass of nitrogen. So really, this part here matches this part down here. They're the same. Okay. And then we changed our, let's see if I can make this a little brighter for you guys. There we go. Then we changed our moles of nitrogen into moles of NH3. We used the mole ratio to do that. So it was a 2-to-1 ratio. So this part here matches this part here. We don't have to calculate in between for this, which is pretty nice. And then our last step was to change from moles of NH3 to grams using the molar mass. So these two parts here are the same. So we are doing all the same conversion parts. The only thing we're not doing is calculating each part in between. We're going to calculate it one time and get one answer here. So just like we do in every other problem, we're going to multiply everything on the top and divide by anything on the bottom. Okay, so we're going to do this in one calculation. Turn my light on here. Oop, got a little brighter there. Okay, so if we look at our calculation, we have 25.5, we're multiplying by 1, so we don't have to put that in, times 2 times 17.04. And then we're dividing by 28.02. And then we're dividing by 1 and 1. If these were other numbers, you would just hit divide again and plug in any other numbers you need to divide by. And guess what? We get 31.01. We get the same value. Because we're doing the same conversions, the same calculations, we just do it all in one step. So setting it up like this is cleaner. It gives us a cleaner answer. We're not getting any rounding errors in the middle, things like that. So the hardest part typically for students on this is just figuring out which conversions to do in the problems. So because there's 3 of them now. So I'm going to show you guys how we can kind of map out our question so that we can figure out what conversions to use and where to go next. So we're going to use this next question to help us. So it says how many grams of hydrogen are needed if 16.75 grams of nitrogen react. So we have our given here, grams of nitrogen, and we would use N2 as we write it because that's what matches the reaction. We're looking for grams of hydrogen, and we would write it as H2 because, again, that matches our reaction. So the way that I look at this is I like to use my chemical reaction to create a map for myself. So the first thing I do is I box the 2 chemicals that I am dealing with in the reaction. So we know we're starting with nitrogen, we're ending with hydrogen. So we don't really care about this NH3 at all right now. We're just trying to figure out if I react to this much nitrogen, how much hydrogen do I need to react with it so I get the right amount of product. All right, the next thing I do is I like to start with my given amount. So we're given grams of N2, so I label that above my chemical. And then we're looking for grams of H2, and that's my question. Now, here's our little story that goes with this to help us kind of think through it. We have 2 little houses, and each of these houses live on Mole Street. Now I'm in my house upstairs, and I want to get to my friend's house and go to their room upstairs. Now I can't jump from my roof to their roof. This is like a big gap. We can't do that. So to go to my friend's house, I first have to go down to my street, and I live on Mole Street. Then I have to walk down the street to my friend's house. They also live on Mole Street. And then I want to go up into their house and into their room, so I go up 2 grams. So this creates a little map for us. I know it's kind of silly, but it works. So we start with our grams of nitrogen, and our arrow tells us we want to go to moles of nitrogen. So that's our first conversion. Each arrow is a conversion. Then we want to change our moles of nitrogen and go to our friend's house to hydrogen. So we're going to change and do our conversion there. So that's our mole ratio. And then we want to go into the house, so we've got to go from moles to grams. So that's our last conversion. So each arrow represents one of these sections where we're changing our units. Okay? And it tells us what we're going to do next. So we can use that map to help us navigate our question. So as always, we start with our given, 16.75 grams of nitrogen. We write that down first. Automatically bring down your units, and then we'll check our map. So we started with grams. We need to go to moles next. So we're going to go to moles of nitrogen. And that's also logically the only thing we can do with grams is change them to moles. We can check up at the top of our paper. Our mass of nitrogen is 28.02 grams in 1 mole per mole. So that gets us to moles. We do our next step. Copy down the unit. We check our map. So we're at moles of nitrogen. Our arrow points to moles of hydrogen. So that's what's going to go on top. H2. We get our numbers. If we're not sure, we can check our lists at the top from our balanced equation, coefficients. Coefficient on nitrogen is 1, and on hydrogen is 3. And then the last step. So we bring down our units automatically, and we check our map. We want to go from moles to grams of our chemical, grams of H2. All right. Between grams and moles, we use our molar mass at the top. Hydrogen's molar mass is 2.02. We put that next to the grams, and it's always per mole, or 1 mole. So we've set up all of our conversions using our little map here. So now we can check our units. They should all cancel. So grams of nitrogen, moles of nitrogen cancel, moles of hydrogen. We're left with grams. And then we can do our calculation. Again, we want to multiply all the numbers on the top, so it would be a good idea to pause and try out your calculation and make sure you're getting the same number as I am. 16.75 times 3 times 2.02 divided by our number on the bottom, 28.02, 3.62. And our units that are left are grams of hydrogen. So what this means is if we react 16.75 grams of nitrogen, then we're going to also need 3.62 grams of hydrogen to have that perfect amount of each to react and make our ammonia, or our NH3. All right, we're going to try one more following this process. So again, first we want to read our question, find out what we're given, what we're looking for. So how many liters of hydrogen are needed to make 432 grams of ammonia? So we're given 432 grams of ammonia. Ammonia is that NH3. It's asking for liters of hydrogen. And again, that's our H2. Okay, so now we can set up our map. So the two chemicals we're looking at are hydrogen and ammonia. Those are the two we care about. We're starting with grams of ammonia. It's asking for liters of hydrogen. So again, we can't jump from house to house. We all live on Mole Street. So we're going to start with our given. We're going to go down to the street. We're going to go walk to our friend's house down the street. and then we're going to go up to their room to see them. So we're going to do a conversion from grams to moles, then change our chemical using that mole ratio, then change to liters. One thing about our liters, we can assume that if it is asking in any of your questions for liters, you can assume it's at STP. It should have been written here, but it's at STP. So we can use the 22.4 liters. All right, so 432 grams of ammonia. So in this question, it's kind of like we know how much product we're going to make. We want to know how much we need to start with to do that. All right, so we're going to automatically bring down our units. We're going to check our map. We want to go from grams to moles. Chemical doesn't change. If units change, chemical doesn't. Only change one or the other one. So we check our molar mass, 17.04 grams in 1 mole. And then we can do our next step. Bring down our units. Check our map. We're at moles of NH3. We want to go to moles of hydrogen. So this is our mole ratio. We want to use our coefficients. So there's a 2 in front of the NH3 and a 3 in front of the hydrogen. And then our last step, bring down our units, moles of H2. We want to go to liters of H2 according to our map. And this is our molar volume. So 1 mole is equal to 22.4 liters. So we can check our units. All the opposites should cancel. We're going to multiply everything on the top, divide by each thing on the bottom. So this is a good one to show you guys the division when there's more than one thing on the bottom of our problem. So we've got 432 times 3 times 22.4. We're going to divide by 17.04. And since 2 is on the bottom, I'm going to hit divide again, because everything is like in reference to that first number. 851.8. All right. Our units that were left are liters of hydrogen. So what this tells us is if we need to make 432 grams of ammonia, we need to react 851.8 liters of hydrogen. So you make that connection there. So these problems, they do get a little more complex, but we're using all the same steps we have been using. And making your little map around your reaction can really help to determine where you're starting and where you're ending. So I really recommend trying that out. All right, thanks guys.